Hello students, I've come before you with a new topic which is to determine the order of magnitude of the numerical value of any physical quantity. So first and foremost, we need to understand the meaning of order of magnitude. Now look, actually order of magnitude gives an estimation, you can say an approximation of the actual value of the physical quantity, right? And it is to be expressed in powers of 10. So it gives an approximation of the actual value, actual numerical value of a physical quantity under consideration, and it has to be written in powers of 10. So that's order of magnitude. Before proceeding further, I'll give you a simple illustration. Suppose a numerical value is 2356 into 10 raised to the power 4. So first and foremost, we need to write this in the standard form. What is the standard form? It is written as 2.356 into 10 raised to the power 7. So that's the standard form, right? Now you need to concentrate on the first digit. If this digit is less than 5, I repeat, if this digit is less than 5, then it is considered to be 1. So in this case it is 2. So it can be considered to be 1. Entire digit, entire numerical value, it can be considered to be 1 into 10 raised to the power 7. So this becomes the order of magnitude. Actually this is the result, which is in terms of the powers of 10, and it gives an approximation of the actual numerical value of the physical quantity under consideration. So that is order of magnitude. Now consider this numerical value, another example. Now consider this numerical value. 6.829 into 10 raised to the power 6. Now look, it is already in the standard form. No need to change it. It's already in the standard form. This is the numerical value. Now the first digit, it is greater than 5, isn't it? It is greater than 5. So if the digit is greater than 5, it is to be approximated as 10 into 10 raised to the power 6. So it will become 10 raised to the power 7. So the order of magnitude of this numerical value is 10 raised to the power 7. So again I am repeating, order of magnitude is represented, of any numerical value is represented in powers of 10, and it gives the approximate value, or rather it gives an approximation to the actual numerical value of the physical quantity under consideration, right? And first you need to write the numerical value in the standard form, and if the first digit is less than 5, then the entire numerical value is to be considered as 1. And if the first digit is greater than 5, then the entire numerical value is to be considered as 10. So that is how the order of magnitude can be easily determined. There is some other method as well. So let's discuss that. So another method is, I will explain with the help of a formula. We need to satisfy that in order to get the order of magnitude. Suppose a physical quantity has a numerical value n. It has a numerical value n. So its order of magnitude is 10 raised to the power x, such that it satisfies this equation. N divided by 10 raised to the power x. It should be, I'll write it again for you. Okay, let me continue. If a physical quantity has numerical value n then suppose its order of magnitude is 10 raised to power x, then it is written as n divided by 10 raised to power x should be greater than or equal to 0.5 and it should be less than or equal to 5. It must satisfy this equation. So again I am repeating, for a numerical value n, its order of magnitude is x, such that n divided by 10 raised to power x is greater than or equal to 0.5 and less than or equal to 5. Right? So what to do is, either you can follow the previous method or mathematically you can follow this particular thing so as to obtain the value of x. Let's take some example, right? Let us consider some example. Suppose we consider the case of radius of Earth. Radius of Earth. It is 6400 kilometer, or in SI it is 6.4 into 10 raised to power 6 meters. So what will be its order of magnitude? So here n is 6.4 into 10 raised to power 6, right? 6.4 into 10 raised to power 6. 10. What should be the value of x over here such that it satisfies this equation? Simple. So if I write here as 6, then 10 raised to power 6, 10 raised to power 6 get cancelled. So 6.4, obviously it is greater or equal to 0.5, but it is not less than 5, so it shouldn't be 6. If it is written as 7, then what happens? This value would be 6.4 into 10 raised to minus 1, so this will give us 0.64, which is greater than or equal to 0.5 and less than or equal to 5. So it satisfies this condition. So the order of magnitude is 10 raised to power 7. So over here it is 10 raised to power 7. Understood now? And by the other method, it has been written already in the standard form. The first digit, it's greater than 5. If the first digit is greater than 5, then the entire numerical value can be written as 10. If it is less than 5, then the entire numerical value is to be written as 1. So, in this case, 6 is greater than 5. So, the entire numerical value will get changed to 10. 10 into 10 raised to 6, that will give us 10 raised to 7. So, that's order of magnitude. Right? Let's consider some other examples as well. Let us consider the distance of Sun from Earth. You are aware it's 1 AU, astronomical unit, that is 1.496 into 10 raised to 11 meters. Now look, here it is already written in the standard form. The first digit, it is less than 5. So it is to be considered as 1. 1 into 10 raised to 11, that is 10 raised to power 11 must be the order of magnitude of the distance of Sun from the Earth. Right? And you can verify this from this equation as well. So in place of n, substitute this value. If you place x as 11, so 10 raised to 10, 10 raised to power 11 cancel, so you will get 1.496, which is obviously greater than or equal to 0.5 and less than or equal to 5. So it will be satisfying that equation. So either way, you can determine the order of magnitude. Let's discuss some other values as well. And these are the values, students, I am mentioning because you need to remember these values. Even if it's not given in a numerical, even if it's not given in any question, still you need to remember these values. Being a science student, these are the values which we should be aware of, right? Like mass of an electron. Mass of an electron. You all are aware of it. It is 9.1 into 10 raised to power minus 31 kg. It is 9.1 into 10 raised to power minus 31 kg. Right? So let's find its order. Let us find its order. Let's find its order by this particular method. Right? So n is 9.1 into 10 raised to minus 31 divided by 10 raised to power x. So what should be the value of x so that it satisfies this equation? If I write in place of x, if I write minus 30, suppose if I write over here minus 30, then what will be the value of this? It will be 9.1 into 10 raised to minus 1. So that will become 0.91. Now 0.91, it is greater than or equal to 0.5 and it is less than or equal to 5. It is satisfying this condition, isn't it? It is satisfying this condition. So the order of magnitude is 10 raised to power minus 30. You can do it by other method as well, as I have told you. Now look, it is already in the standard form. It is already in the standard form. The first digit, it is greater than 5. So the entire numerical value may be converted to 10. 9.1 may be written as 10. So 10 multiplied by 10 raised to minus 31, that will give you 10 raised to minus 30. So the order of magnitude of the mass of an electron is 10 raised to power minus 30. So you can make use of either method, right? Let's discuss some other values as well. Okay. Charge of an electron. It is 1.6 into 10 raised to minus 19 coulomb. So this is the charge of an electron. Now look, this is already written in the standard form, isn't it? So what to do is, 1, the first digit, it is less than 5. So the entire numerical value may be considered to be equal to 1. So 1 multiplied by 10 raised to minus 19, it will give us 10 raised to power minus 19. That's the order of magnitude, right, of the charge of an electron. Suppose, let's find out the order of magnitude of distance of moon from Earth. I think I told you already. It is about 3,84,000 kilometers. This is the distance of moon from the Earth. First you need to write it in the standard form, right, in SI. So it can be written as 3.84 into 10 raised to power 345 and kilometer is 10 raised to power 3 meters. So it will be 3.84 into 10 raised to 8 meters. Look, I have converted kilometer into meters. 1 kilometer is 10 raised to 3 meters. And by placing decimal over here, 3, 4, 5, 10 raised to 5 into 10 raised to 3, that will become 10 raised to 8. Right? So now consider this value. This is in the standard form, right? So the first digit, it is less than 5. So this entire numerical value may be considered to be equal to 1. So it will give us 10 raised to power 8. So the order of magnitude of the distance of moon from the Earth is 10 raised to power 8. And its actual value is 3.84 into 10 raised to power 8 meters. Fine? Let's consider some other case as well. You are aware of Avogadro's number. It is 6.023 into 10 raised to power 23. These are the number of atoms present in 1 mole of a substance. So again, it's already written in the standard form. It is already written in the standard form, right? So basically, we consider the first digit, it is greater than 5. So it is to be approximated as 10. So 10 multiplied by 10 raised to power 23, it will give us 10 raised to power 24. Clear? Another interesting point, height of Mount Everest. I think we all should know it. It is 8648 meters, approximately 8648 meters, right? So first we can write this in the standard form. So what to do is, we can write it as 8.648 into 10 raised to power 3 meters. This is the first step, to write it in the standard form. Consider the first digit. It is greater than 5. So the entire numerical value has to be written as 10. So the order would be 10 raised to the power 4. So if its height is 8648 meters, its order would be 10 raised to the power 4. Right? Let's take another example. Height of a man. Suppose we consider height of a man. Height of a man varies, right? We can take it to be approximately from 1.5 meter to 1.8 meter. Suppose it is 1.8 meter. So 1.8 meter, it has to be written in the standard form. So what will be the standard form then? 1.8. It can be, because order of magnitude has to be expressed in powers of 10, isn't it? So over here, n is 1.8 meter. It can be written as 1.8 into 10 raised to the power 0, isn't it? So what I mean to say is that anything to the power 0 is unity, that is 1. So we can write it like this. Now this becomes a standard form. First digit of this numerical value is 1, which is less than 5. So it is to be considered as 1. So answer is 1 or 10 raised to the power 0. This is the order of magnitude of a height of a man. I hope you have understood the concept. Right? It's very simple. Make use of either this mathematical expression or directly by converting the numerical value in the standard form, you can easily apply that rule. If the first digit is less than 5, then replace the numerical value with 1. And if the first digit of the standard form is greater than 5, replace that numerical value with 10. And accordingly, you can obtain the order of magnitude of a given numerical value or a given physical quantity. Right? So students, this topic is over. Let's try some simple numericals based on finding the distance of astronomical objects or finding the size of astronomical bodies. Right? We have discussed various indirect methods. So let's discuss some numericals based on those topics. Right? So let us assume the angle of parallax, subtended by two diametrically opposite points on the equator of the earth by any heavenly body is 1 second. What will be the distance of that heavenly body? Right? So my question is, listen to me very, very carefully. Let's try this first question. This is earth. This is the diameter of the earth. This is A and this is B. These are the two diametrically opposite points, right? Obviously, AB can be considered to be the equator. So these are the two diametrically opposite points on the Earth's surface, right? And there is a heavenly body. There is a heavenly body. So the angle of parallax, it's given to be 1 second. 1 second, it's written like this. This is 1 second. It's the angle. In sexagesimal system, it can be converted into radians as well. That we'll discuss. So, what will be the distance of this heavenly body from the center of the earth? Right? This is the question basically. So, question is, a heavenly body subtends an angle of parallax of 1 second from the 2 points on the earth's surface which are diametrically opposite to each other. Determine the distance of this heavenly body from the center of the earth. Now, as I told you, this distance is huge or very, very large as compared to this distance, right? So, AB, it can be considered to be an arc subtending an angle 1 second at the center of a circle of radius x, right? So, what was the formula? You are aware, angle is equal to length of the arc divided by radius, which in this case is x. Therefore, x would be equal to length of the arc divided by angle. Right? This is the thing which is to be used over here. X is the distance of this heavenly body from the center of the earth, which is our objective, which we intend to find. Now angle is given to be 1 second. And AB, as I told you, this is very small as compared to this distance. So it can be considered to be the diameter of the earth. So if R is the radius, then it will give us diameter, that is 2R. Angle is 1 second. Now we need to convert it into SI so as to get the value of distance of this heavenly body in meters. I have told you this. 1 second is equal to pi by 180 into 60 into 60 radian. This we have already discussed. Right? So let's substitute the value and we can get the result. So x, it will be equal to twice. Radius of the earth, students, it is 6400 kilometer or 6.4 into 10 to the 6 meters. Divided by 1 second, it is pi over 180 into 60 into 60. Right? So substitute this value and you will get the answer in meters. I hope this can be easily done by you. Right? So this is the concept involved over here. So students, while solving numericals, don't forget to follow a single system of unit. Here I have considered SI. So I have written distance, that is the distance between points A and B in meters. Angle, its SI unit is radians, so I have converted angle of 1 second in radians. Substitute this value over here and you should easily get the answer. Right? Let's discuss some other question as well. Second one, based on indirect method only. So what we assume is, this numerical is based on the actual fact, right? The angular diameter of the sun, it's found to be 1920 seconds, 1920 seconds. So what will be the size of the sun? What will be the linear size of the sun? Right? Let's do it. So this is Earth's surface. Sun is at a very, very far away distance. So it is shown to be quite smaller. Right? So this is Earth and this is Sun, which is at a very, very huge distance away from us. So it is shown to be quite small. Question is, this is a telescope and the angular diameter. This is the diameter of the sun, AB, and the angular diameter. I am talking about this angle. This is the angular diameter. This angle is given to be 1920 seconds. This is sun. Right? So, this is the diameter. So, diameter of the sun is to be determined. Only by knowing this information, the diameter of the sun is to be determined in meters. So again I repeat my question. The angular diameter, this is known as the angular. This is the angular separation between these 2 points. So it's known as the angular diameter of the sun subtended at a point on the Earth's surface is 1920 seconds. Find out the linear size or the diameter of the sun. So what you do is, this distance is suppose x, right? Now again, x is very, very large. So OA and OB, it can be considered to be radius and AB can be considered to be an arc of a circle subtending angle theta and of radius x. Again the same basic formula, angle is equal to length of the arc divided by the radius. What is the angle subtended? 1920 seconds. What is the length of this arc? It is equal to the diameter of the sun. And what is the radius? It is the distance of the sun from the earth. Right? We need to find d. So d would be equal to x multiplied by 1920 seconds. Now look. X, it is the distance of sun from the earth. It is known as astronomical unit. And it is equivalent to 1.496 into 10 raised to the power 11 meters. So what do you get? 1.496 into 10 raised to 11 multiplied by, now look, you need to convert the second into radian. 1 second, I have told you, it is pi by 180 into 60 into 60 radian. So therefore, 1920 seconds would be 1920 into pi divided by 180 into 60 into 60. Right? So don't forget to convert this angle which is given in second into radians. So now this can be easily solved by you. So we can get the linear size or the diameter of the sun in meters. So basically, student, this is the approach. Again, I am stressing on the fact that while doing numericals, always mind the system which you are using. All the units should be expressed only in one system. Here we are dealing with, or rather we have considered SI system. So that the result is also in meters, the angle is considered to be in radians. Right? So this is another application whereby using indirect method we can determine the size of sun, right, by using this concept. I hope you have understood this topic, and as I very often advise you to solve more and more numericals, to practice more and more numericals, right? So all the very best. We'll continue in the next session.